like it, then there's not much you can do about it. Right? If you say, well, no, I don't want to use Atom Pub. Sorry, that's just the way it works. Well, I don't want all the, stuff that it does, and too bad. It works the way it works, okay? If you like it, it's great. If it's not what you like, then it's not for you. So actually, ADO.NET Data Services is built as a layer on top of WCF. So if you don't like what it does, you can go down a layer, right, with WCF, and then you can control everything. And you can do it exactly how you want. So I would just say, if you're happy with data services and you like the way it works and it does what you want, great. That's the end of story. You don't need to do anything else if you don't want to. There's actually a session this week. Pablo Castro's given a talk about, I think his session's called Modeling REST or something like that. So you can hear more about data services and how it works. Okay. We got about a minute. Yeah. Oh, interesting. Okay, so the comment was, in case you didn't hear it, why do you call it RESTful services for the programmable web when there's not really a service in REST? That's a good question. I picked that title from, based on the Holy Book of REST. It's the RESTful Web Services book by Sam Ruby and Leonard, I can't remember his last name. Anyway, Sam and Leonard wrote this book, the RESTful Web Services book. It's probably I call it the Holy Book of REST because it's the sort of definitive REST book, if you will, other than Dr. Fielding's PhD thesis, which is impenetrable by mere mortals. So he calls it RESTful. They call it RESTful Web Services, so I just went with it. But you could argue that. Okay, let's get started, and then we'll dive in. So here's the ground rules for today. As we have this talk, I'd like to be interactive. Feel free to interact and raise a hand, shout out a question. You know that these will be, the session is being recorded. You will appear on the web in all of your glory. If you want to be really glorious, you will stand at the microphone and boldly declare your question so that the world will hear your voice. On the other hand, if it's too much hassle, you can just shout it out and I will repeat your question. Okay? So that's the way we're going to do it. And let's begin. I love this picture. In fact, I saw that this picture was in the keynote. This picture, I often ask people, what do you think that is? And of course, everybody in this room knows what that is. But very often people will say, oh, that looks like a neuron. It is very interesting. It does kind of look like a picture of a bunch of neurons working together, like a neural network. And for those who don't know, this is a picture of the internet. In 2005, some guys wrote a little app that kind of crawled the internet and mapped out servers and drew links between them. And this was actually about 30% of the internet at the time. And they mapped it out in this kind of style. But it is very interesting. I draw this picture just because when part of me always wants to ask the question, why? Why is this interesting? Look, we can do a lot of things with our time, but ultimately, and by the way, there's seats kind of spread out throughout in here. If you guys feel free to come in and scrunch in and get to know each other. Okay, I believe that when historians look back on this era, perhaps even greater impact than the end of the Cold War, and about the same time, 20 years ago. In fact, the anniversary just passed when Tim Berners-Lee wrote the first memo describing the World Wide Web, March 13th, 1989. And the invention of the internet has dramatically changed everything about our world, everything from the way that we do things to the way that we communicate and the way that business gets done. And initially it started out just as like a good way to replace those brochures that we're always printing up. And businesses said, we could put our brochure on the web and then we wouldn't have to pay the printer. And that was a great start, and it was the first place where people kind of began. And I asked the question, why does the web work? Hang with me. I know this seems foundational. It is. The web works because it's simple. It just is. I mean, frankly, you look at a lot of things on the web and you say, wow, that's really simple. I mean, couldn't we have done it better? Yeah, we could have probably made something more complicated. SMTP is a great example. It's simple, but it's kind of stupid in that it allows spam and there's no way to verify senders and things like that. But, you know, these technologies grew up at a time when people trusted the web. Okay, but they were simple. And, in fact, the web scales amazingly well. And it has from the very beginning. I remember my first, 1200 baud modem. I know some of you had 300s, okay, but I started out at a 1200, okay? And when I first got online, seeing the pictures that appear like plink, 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 you remember that? Okay, but the web scaled, even at that time, with very, very lousy bandwidth because it was heavily cached. And not just heavily cached in your browser, but cached throughout the web infrastructure at your ISP, various gateways and content distribution networks. There's a lot of caching that goes on in the web. This is why it's globally scalable. And it tends to work best when it's kind of stateless, that each request sort of stands alone. But mostly it works because people find value in it. Why do they find it valuable? Because of links. Think about it. The web would absolutely suck if there were no links. It would just be stupid. Okay, but links make everything possible. I can search, I can go click on this link, I follow it to here, I go to your blog, I click on a link there, I go to somebody else's blog, it's great. And links bring value to the web. Now, why am I saying all this? Because in the past, when people realized there was a lot of value in the web, but not just as a replacement for brochures, but as a way to do business, they asked this question, well, how do we move from this web of pages to a web of services? Because then we can really do some valuable things. And the first answer was SOAP, right? Hey, we got SOAP services. And the designers of SOAP got together, and they set out to solve a specific problem, and that specific problem was machines in the data center that are incompatible. I got a Microsoft machine, and I got a Sun machine, and they can't talk together. And their legacy and their history was things like Corba and DCOM, and they said, let's make a layer that can communicate in the data center, and it can do things that we want to do in the data center, like transactions and deep security and a lot of powerful stuff. It was very, very cool. And then there was this other group of people that said, no, wait. The web of services should work the way the web of pages works. And you say, but wait, I thought SOAP works over HTTP. And it does, but it does not work the way the web of pages works. It just doesn't. It does everything over HTTP post. So the way you could think of it is like SOAP messages like to tunnel through the web. They're sort of opaque traffic as far as the web is concerned. And so the web doesn't want to cache them, it doesn't want to deal with them, it doesn't know anything about them, and it just works differently. And you know what? The designers of SOAP did this intentionally. They made a design decision that said, we want to be transport independent. So today, with WCF, you can create a service that communicates over HTTP, it goes over TCP, MSMQ, name your channel, you can create your own. It's great. It's powerful. It's super cool in the data center. But on the web, it does not work the way the web of pages works. Now, I have to confess that I stand before you today in fear and trembling as I recognize there is a vast divide in the community over what exactly REST is. If you haven't discovered this, try blogging some strong opinion about REST. Sooner or later, someone will come along and say, well, that's not very RESTful. Or your service would be more RESTful if you... In fact, the other day, I was just, kind of reading different blogs. I ran across this guy's blog of some very cool thing he did, and I liked it. It was very cool. He showed his work, and then somebody commented, You should remove the word rest from every place in this blog post because what you've done is not restful. I went, oh my God, can you feel the hostility here, right? And he linked to the Fielding's blog. If you don't know the Fielding, he is the man who coined the term rest. And he is Dr. Roy Fielding. As part of his PhD thesis, he wrote, or dissertation, I should say, he wrote this term rest, which stands for representational state transfer. So I went and read the Fielding's blog. And as I said, mere mortals can only hope to understand the wisdom of the Fielding. And we grapple with it. So the Fielding is what I call a high rest person. This is not my term, but the community term. And then there are low rest people. Low rest people are like surfers. They're just like, yo, whatever, dude, you know, you just want to post some XML, it's cool, I'm fine with that. Query string, whatever, man, just whatever works. I mean, these are the POX people, just plain old XML or JSON or whatever works. And they don't want to get in endless debates about restfulness, okay? On the other end are the accountants. Accountants have rules, and there are rules to rest, and you must follow the rules. And if you don't, I'm going to say, you're not very restful. Okay. I never heard this about soap. I never once in all my years had somebody say, well, that's not very soapful. Or you're not very soapy. Or whatever they would say. I don't know what they would say. It's different because with soap there is a specification. It either is or is not. You can run automated tests. They tell you that is soap, that is not. Rest is not like that. Rest is an idea. It's a style. It's a feeling. And you can never know if you are truly restful. Okay. In fact, I think these people on the high rest side, sometimes we call them restafarians, look at soap as though it causes global warming. Yes, it's industrial strength, but it's difficult. It's powerful, but it's complicated, and it's all specifications, and you tell me exactly what I have to do. On the other hand, I think restful people would say that rest is the solution to global warming and that it's simple and lightweight. It produces less greenhouse gases. It's good enough, even though it might be less functional than what soap is. And it gives you all kinds of freedom to do what you want to do. Now, some people have positioned this as a war between soap and rest, and that one or the other is going to emerge as the ultimate victor. We like to say that we are all about the peace, okay? And that each of these technologies, soap and rest, were born into a context where they make sense. Soap has some distinct advantages in the right context. In the data center, has great advantages, very powerful capabilities, and doing a web service, a SOAP service over TCP with binary formatting is amazingly fast. Flowing distributed transactions, super intense security. It's awesome. It's great. But on the other hand, if you're writing JavaScript that runs in a browser, you can't consume that thing. So you'll probably favor rest. It's okay. I'm not about trying to claim one side is superior or the other. I just want to say today we're going to be very pragmatic. So I'm more like the surfer, okay? Pox, dude, whatever you want to give me, it's okay. And today we're going to talk about it from that context. Now, a year ago when I first started looking at REST, I remember sitting down in my office one day, I said, I'm going to create a RESTful service. So I started with the SOAP service, and after a day and a half of struggling, I finally made a REST service. Okay, maybe that's just me. I might be stupid, okay, but that's how long it took me to kind of figure out how to get a RESTful service with WCF. And I made a video. Many of you might know that I've done podcasts over the years at Microsoft, and I have a show now called Endpoint TV. I did a show called Artcast TV before that. So I made a video. This time I made it for internal eyes, and I made a video, and I said, this is why this is really hard to do. A 15-minute video, and I showed it around to the development teams and the executives and all that, and I said, this is way too hard. It ought to be simple. It ought to be like go in Visual Studio, file new, REST service, F5, runs. That's what it ought to be, but it clearly was not. So we created the WCF REST Starter Kit as a way to get you to that kind of experience. File new, F5 run, psh, you got a service. Are we done? No. We got more work to do. We just shipped last week the Preview 2 release of the REST Starter Kit. It's good. It's got some very cool stuff in it. On the server side, I think we still got some work to do to make it even easier. Okay? We're trying to make this as easy as possible. But anyway, REST Starter Kit, Preview 2 just shipped last week. It's pretty awesome. You want to check that out. I'll have more URLs on that later. What's in it? We have templates. So there's templates for creating a service, and there's project templates and item templates and things like that. We have built integration with the caching infrastructure of ASP.NET. So however ASP.NET caches, you can cache your RESTful services the same way. Okay? And it's attribute-driven. You can put a little web cache attribute on your service. You can put some config entries if you want, or put it in the attribute. Either way. We integrate with the security of ASP.NET. Plus, we do something that we can talk about in the Q&A if you want to, which is kind of the ability to do API key sort of security, which is something commonly seen in REST services. We automatically generate a help page for you. I'll have a screenshot of that later. There's this whole client library I'm going to show you in just a moment. We put all of this on CodePlex, including the full source code and the unit test. It's really nice. So, you know, I wish, honestly, I wish we did this for all of .NET, really, but we're not there yet, okay? But it's really cool because, you know, then when you're working with it, you go, what does that class do? You know, go right to it, and you can see exactly how it works and what it does. It's very helpful. Some of these features are already being rolled into .NET 4. Okay, and you'll see some of them in the Beta 1 release of .NET 4 when that comes out later this year. And basically what we're doing is we're listening. What do you say? And when you feed back to us, you have impact in shaping this. So we want you to look at it and tell us what you think. All right. Now let's do a little demo, and if the demo gods are smiling, we shall be good and no blue screens. Okay. So let's take a look at, here's Twitter. So I'm not a great Twitterer, okay? My tweets are kind of stupid. I don't know. Maybe it's just me. I can't figure out what useful thing I can say in 100 characters or less. Okay, but anyway, I've been, you know, kind of playing around with Twitter, and I have been tweeting things, okay? And so I thought, well, it'd be kind of interesting to look at a Twitter app, okay? So let me go back to my other project here, and we'll save all this because I'm going to come back to that demo later. And so what I want to think about first is just what is it like to consume Twitter? Okay, so when we use this term, the programmable web, it's just a way of saying that websites who have data, very often they want to share their data with the world. And, you know, you would think, wouldn't that kind of work against them? I mean, you know, if they're driven by ad revenue, if I can just get their data without looking at their ads, it seems like that would sort of work against them. But on the other hand, it works for them because it extends their reach and influence in the world. So then when suddenly you've got all these people linking to you and using your thing, and you become more and more powerful on the web, then you can command more dollars for your ads. Okay, and so the programmable web is the idea that if I got some useful thing on the web, maybe I had to share it so that other people could call it. I might want to restrict how they use it, but nonetheless, I'm going to share it. So Twitter has done this. So in fact, if I copy this string, okay, and we come over here to Twitter, let's go to just a new tab and paste this in. Now I'm consuming the API directly, okay, instead of through their page. So it wants me to log in. So let's log in here. And we see my status from their Twitter API. Okay, so they're sharing their data. I'm looking at it in XML. I can get it in JSON if I want, or you know, whatever. It's kind of cool. So I can consume this data and work with it. Now, somebody was asking earlier, well, what if I want to write a desktop application that consumes this programmable web stuff? Can we do that? Absolutely. That's what this client library is about. So let's think about that. So the first thing I want to do, I left myself little notes so I wouldn't forget what to do next. First thing I've got to do is if I'm going to consume this XML that Twitter sends me, I mean, you know, look at that. Now, some people are great at you know, DOM or, you know, whatever else, X-Link and all kinds of stuff. I'm not great at that stuff. I mean, I can do it if I have to, but I'd rather prefer to work with kind of a strongly typed thing. Now, in SOAP services, it's easy, right? Because I just say add a service reference. I get a nice strongly typed generated proxy. All the types are in there for me. That's because SOAP has this WSDL thing, right? REST does not have WSDL. And the fielding would probably turn over, if he were dead, he would turn over in his grave if we created something like that. Okay, the fielding is clearly opposed to this sort of thing. Now, so yet I want to consume this. How do we make this easy? All right, so let me show you what we did in the Preview 2 release. If I come in here and say view source, great. Hey, that's just lovely. Okay, it's unavailable for. See, I've never seen that. That's never once in my whole life ever appeared, right? What is up with that? Okay, let's try it this way. I don't know if this will work, but oh wait, I know how I can do it. I have Fiddler running. Yes, okay. So I can grab it from Fiddler. Fiddler, by the way, is a free HTTP debugging proxy, so you can just run this and see what's going on at the HTTP level. And so let me scroll okay, there we go. Now I've got it. Dang. There's just weird stuff that happens. You want to see weird stuff happen, try a demo in front of people. Something unique will always happen. All right, so now I've copied that XML to the clipboard. I'm going to do this, paste XML as types, and voila, something magical just happened right before your eyes. We have analyzed the XML that was on the clipboard, and we created serializable types based on what we saw on the clipboard. Is it perfect? No, my friend, it is not perfect. It is close, okay? For example, this lovely little thing here, the followers count. Now, it looked at my measly little following on Twitter and said, well, a byte can hold that. Now, on the other hand, if we were looking at Mr. Hanselman, then it would obviously declare it as a long or something like that, right? Okay, so you might want to change it. You know, you can change types and things like that. I don't need to change it because it's just me, right? All right. Anyway, you get the point that I can declare this type. Now, because I wanted to be safe, I did that in a file that I'm not going to save, okay? I did this earlier. Beforehand, I prepared this and stuck it in the oven, all right? So there it is, the Twitter client types. Now, I wrote a little console application to make this simple. So the first thing I want to do, I made these fonts super huge, and I looked from the back of the room because I think you can see them better, but we'll see. The first thing you'll notice is there's a new client library class called HTTP client, okay? We've had the ability to consume HTTP in the platform before, right? It's always been there. There's a class called HTTP web request. That's a mouthful. It's an okay class, but there were some things we didn't like about it. And it was sort of a pain to work with, and its interface felt very .NET 1.1-ish, you know, kind of just not very cool. So we rehashed this thing and made it much nicer. So first thing I did is I knew up a client, and then I set some transport settings. So I need to pass my Twitter username and password. Yes, it is in the file, but I'm not sharing the source with you. Okay, so I just knew up a network credential and set that on there. And then I just called this method show Twitter, which is going to deal with the response. And I just say client get and that Twitter URI that we passed in earlier. That is darn clean, right? It's very, very simple. Nice little interface. Let me take you to show Twitter, okay, and we'll look at what that is. Scroll that up a little bit. Okay, so what I pass in, what the client.get returns for me is this new class HTTP response message, okay? And all I have to do in here is say, using response, because remember, I'm dealing with an HTTP stream, okay? So reading from the stream, I got to be sure that I close it. The response message owns the stream, and it's disposable, so I must close it. But here's where the beauty comes in, my friends. The beauty is right here. I just say response.content.read as XML serializable of T. So statuses. So that little thing I pasted in, there was a type in there called statuses, which is the main type of what Twitter returned. Is strongly typed, and I just say, read it as XML serializable. Now, you know, you could have done this before. You just had to write more lines of code, right? You had to declare a serializer, get a stream, push in, deserialize, and all that. We just wrapped all this up in one very nice little package. And so, okay, yeah, it's just complaining because I pasted that in earlier. All right, so then I can just go for each. Sometimes the names that it gets out of the pasted XML are just a little weird. Just, you know, it's kind of trying to figure out names from the structure. So I have status is status. But I just for each them, and then I'm going to write out what my status is. And so let's build this sucker. And I'm going to consume it synchronously. And there it is. There's my little Twitter status, right, consuming from that thing. And we're just talking just a few lines of code, right, to get some very cool stuff out of this. Now, let me make a couple of observations about these things. The way this is structured in the client library, if you go download the kit, you will notice there is a new assembly called Microsoft.http.dll that comes in the REST starter kit. And there's another one called Microsoft.http.extensions.dll. Methods like read as XML serializable are extension methods. Okay, it's a C# 3.0-ism. And one of the things that's a little weird about extension methods is that IntelliSense won't show you the extension method unless you reference the assembly that it lives in. And then to use it, you have to put the using of the namespace that the extension method lives in. So read as XML serializable, even though it lives in the HTTP extensions DLL, its namespace is system.xml.serialization. Okay, so you have to include both. Add a reference to the assembly, put using XML serialization and all that, you'll be fine. Okay, so that is pretty darn cool. Now, somebody was asking me about this and said, well, I want to consume async, do async I/O, which is a good point because if you ever listen to Jeff Richter talk about threading, he's going to bang you on the head and say, you should always, always, always do async I/O, especially on a server. And frankly, it's not that hard, so let me just show you how I did it. Again, I use the HTTP client class here. Same thing, I set up my username and password. And then all I have to do is say client.beginSend. Okay? In this case, I can't just call get, because get is actually an extension method that always calls the synchronous one. Okay? If I want to do async, I have to call beginSend. I new up an HTTP request message. It's going to use the get verb. Here's the URI. And then I give it a callback, an async callback, on send completed. Okay, but if you're used to JavaScript in async, Ajax, you got callbacks, it's no problem, right? And then I can pass along some state that I want to use in the callback. Okay, so I'm going to pass in that client object so I can access that in the callback. Now the way this works is when I do begin send, this is the beauty of it, is that we send a request packet to the network device driver. And we say, Mr. Device Driver, we want to make an outgoing request. We're going to send this, and then we're going to go to sleep. And when you get a response back from the network, please wake us up on whatever I/O port thread, completion port thread you happen to be using, and call us back. So that's what is going to happen. So the send completed method is right down here. Okay? Yes, I could have done this as a Lambda expression. You can do that. It just looks a little convoluted, so for the demo, I did it this way. So I get back this some object that implements the iAsync result interface. Okay? And from that object, I need to get the HTTP client. So I'm going to declare another one here and grab the result.async state and cast it to an HTTP client. Now that I've got the client, now I can read the response, okay? So again, I put this inside of using. So I say, scroll it up. All right, so I say client.endSend. So these async methods have the begin and end pair, right? And I pass in the async result. Now it's going to grab the response pipe out of there, and so once again I can show the Twitter using the async result. Okay? Now, what makes this a little more interesting is the fact that because I'm doing this asynchronously, I had to use a wait handle, right? Because this is a console app, and so my console app would go begin send, bloop, I'm done, and the app would end, and we'd never see the result, right? So I put in a wait handle. This is an auto reset event, and I just said, okay, this thread that calls begin send is going to call it and then wait. So this thread's just sitting there waiting. Send completed gets called back on a IO completion thread. So the device driver actually calls us back on its thread, and then we can do the work. Once we've got the response, then I can down here call done.set. Now, I put this inside of a finally block because good programmers would never let the main thread get stuck forever. Okay, so if an exception happened or whatever, we'd still let the main thread go. Now, granted, if there was an exception, I might want to catch it and do something useful. I'm not doing that here, of course. But anyway, I decided to put at least that level of goodness in here. And of course, if I hit F5 and run this, it's just going to do the same exact thing. Okay, so that's kind of pointless, right? But anyway, let's do it anyway. All right, so I press A for async, and pooh, there it is, right? Now, if I were consuming a RESTful service from a server application, any kind of server application, I would definitely, 100%, every time, use async IO. No question about it. Okay, but somebody said, well, I'm building a client app. I want to do async IO from my client app. Yeah, you probably do, but there's interesting challenges about async IO and client apps and marshalling threads and all that kind of stuff. So we actually built into the starter kit a different model that's more of an event-driven model for doing async IO. And so to show you that, let me switch over to the other app here, which is my lame attempt at WPF. I am just a WPF rookie, okay, I promise. So I have a little app here that's using a model view controller style interface. And so I'm going to show you one other thing here in my app, which is the polling interface. Okay. Now, imagine I have an app, and I want to go off to the web, and I want to get something. And then I want to, every now and then, because my client app's just sitting there, I want to poll the web and say, has that thing changed? And if it's changed, I want to get the new representation and show it. Okay? Well, it turns out that HTTP has a nice mechanism for this. It's called conditional get. Okay? And a conditional get allows me to send some special headers, like if modified since and if none matches, and say, I'm going to send these headers, and Mr. Server, if the thing I'm asking for has not changed, just let me know. And the server sends back a HTTP status code of 304, not modified, okay, and no response body if the thing has not changed. Okay, but if the thing has changed, then the server will send you back a 200 and you get the new data. So this way, my little app here can kind of poll every so often and ask for what's going on. So we created a polling agent in the starter kit client library, and all I have to do to use this thing is just new up the polling agent here. I just new it up. Nothing interesting there. Then I can say what the polling interval is, right? So I'm going to say we're going to poll every 5 seconds for this demo. I pass in an HTTP client object. I can new up one or use an existing one. And then I just add an event handler. So this model for async, this is going to use the event-driven async. So I have an event handler here that's going to get called when there's something going on, and then I just start polling. And here's where I get my call back. So there's some cool things, some goodness here. Like one thing I might want to check is, what is the status code, HTTP status code? In this case, I'm saying I want to make sure that it's 200, okay. If it's something else, this little ensure status is going to throw an exception, okay? Now, very often, There's several status codes that are okay. You might say 200's okay, 203's okay, whatever, pick your numbers. I can actually pass a whole list of status codes to this method, and it'll be okay if it's any one of them. And so then I just come in here and get my stuff and show it. So let's run this up here. And oops, you know what? Let me start Fiddler first. Oh, it's already running. Okay. All right. I'm going to fire this up. And let me minimize or change Fiddler here so we can see both of them. Okay. So I'm going to say poll for changes. Go over here and get my tweets. Okay. And there it is. It's doing its thing. And you can see every 5 seconds or so, it's going to fire off a request again. Interesting note that what's happening here in Fiddler is it's sending me back a 401, which means unauthorized. Right? It's challenging me. The first time I try to access it, every time Twitter's saying, you must authenticate, you must authenticate, you must authenticate. Right? So the authentication is not showing up here because it's happening over HTTPS. But anyway, then I get my data back 200. Now, this is what causes this demo to blow up. Because, look at this. Let me just stop this app, and I'll show you something. I wanted to show something really cool, like my app would suddenly refresh when I tested my Twitter feed. And I found that Twitter always returns 200, even if the data has not changed. So they're kind of being brain dead. Okay, but look, in the headers, I'm passing if modified since and if none match. Now, they're returning in their response an E tag, an entity tag. That's one of the ways you do conditional get. So they're telling me, yeah, we do conditional get. And then when I pass them the headers, they're going, no, we don't do conditional get. Here's a 200. So anyway, kind of blew up my demo, but that's their fault. So, OK. Let's go back to that's the fun of this kind of stuff. We had actually some interns work for us for the summer, these two college guys, and we had them look at like literally every RESTful site that we could find and document how exactly things work. And here's what we found, is that there is a wide variety of the way people do things in REST, and there's no standard way. And many times what people say they will do, they don't do, and things like that. So it's all over the map, okay, as far as consuming REST things out in the world, and you just have to kind of test them and see what happens. Now we're going to talk about the other side of the equation. What if I want to create a RESTful service? How do I think about that? The important thing to remember is that you must think differently than you do when you create a SOAP service. The mindset of the SOAP developer is about actions, right? SOAP has a SOAP action. It's verb-oriented. It's like, do this, get that, update this. It's verbs, verbs. But in the world of REST, it's about resources. And the verbs are all decided for you. HTTP has verbs. It has a set of verbs. You're going to use their verbs. You don't get to think of verbs. You get to think about resources. Those are nouns, customers, conferences, sessions, things like that, resources. So you're always going to start by thinking of the resources that our service wants to return. Now, when I started making RESTful services, my first thought was, OK, I'm going to make a service, an API. I'll have a SOAP API and the REST API, and then you can choose which one you want. They're basically mirror images of the other. RESTful people would say that is not very RESTful, because your SOAP API will look completely different than your REST API. But the business logic that supports both of them could be identical. Okay, but the APIs will look different. All right, so let's think about how do I declare the resources. Okay, I'm showing you how you do this in WCF, okay? And we already mentioned that there's other ways to do REST with data services or MVC or other ways. So everything I'm going to show you is WCF oriented, so remember that. The first thing you're going to do is define a resource. And so it's just a simple class. The thing I like about this class is it's so dead simple. There are no attributes on this class, right? No data contract, no data member. We made changes in WCF and 3.5 SP1, so we don't require those things anymore, largely for RESTful people, because they hate data contract and data member. They don't want to put that stuff on there. It's OK. So you don't have to. You can if you want to. You don't have to. So that's all I got to do is define some class as my resource. It should be very simple, has just the data I want to send, and probably no behavior at all. It's just kind of a container, right? Now, what format am I going to return to the people who are consuming my service? One of the principles of the web is that there's content negotiation. When your browser sends a request, it can specify what kind of content it wants. And we do that with MIME types, right? So you can say, I want text wax XML, or I want application wax JSON, okay? And the HTTP spec says that as a server, the server ought to look at that and honor the request if it can, right? So it could be that I'm serving up, conference data, like evaluation scores, and you ask me for a JPEG image. Who knows? Maybe my server will whip up a chart and return you a JPEG image instead of JSON data. I mean, it could do something like that, right? So there are different methods that people use to get this done. Twitter likes to use the extension method. They put, .xml or .json. Other sites like Yahoo likes to use a query string parameter, like !, format equals, or some people like to use the accept header. I found that most RESTful people do not like using the accept header because they think anything that's not in the URI is kind of extra out-of-band baggage. And they don't like that. They want to see everything about the request in the URI. So take your pick. Now, the next step up the ladder of creating your service, or the stairs here, as you see, is the URI. We heard some talk about that this morning with the Stack Overflow guys. We're talking about how the URI is important. Making simple URIs helps in the search engine optimization. And so you want to be able to control the URI, and you're going to think about the structure of the data. So here is a table where I've thought about, I'm imagining a conference service, okay? So we have a conference. Conferences have sessions. Okay, so I'm going to create a service that returns data about sessions. So I have my session service. And if you just call session service with an HTTP GET, I'm going to give you all the sessions. If you want to see a specific one, you pass session service WAC ID, and you get a specific session. Then if you want to add a new session, you could post some XML to the session service. If you want to update a particular one, you're going to call put. And if you want to delete one, you call delete, right? So that's very often you'll find REST people kind of describing their API in some manner like this, some sort of table. And of course, the third step is you're going to go and implement your service. So let's talk about how you implement a service. Now, I know that WCF has a reputation as being complicated and complex. Let's just be honest about that, okay? It's true. Some of the stuff you've seen, I know last year I saw the session from MIX where the MySpace guys wrote an OAuth channel, and I looked at their code, and my head wanted to explode when I saw this, WCF channel, and I said, I don't want to write that, okay? You don't have to write that. We've made it real simple. Look at this very simple class here. You just say get session, and I return one of those session data things. Okay, and I went and got it out of some data layer or a store. I have a dictionary here. But that's all you got to do, right? It's just a class. It has a simple method. It returns something. Okay? Now, the next step is to turn it into a WCF service, because that first thing you saw was just a class. WCF wants me to put a couple of attributes on this to tell the WCF runtime, so this class is a special class. It's a service. So I put a service contract on the class, and I put operation contract on the method. Okay, at this point, I've created a SOAP service because WCF, by default, wants to do SOAP. Okay, so to make this RESTful, I have to take another step. The next step I'm going to do is I'm going to add a reference to systemservicemodel.web, and I'll put using systemservicemodel.web, and I'll put webget on my method. Now I'm saying to WCF, this service wants to use HTTP with the get verb and call this method. We're no longer using SOAP. Okay? This is now REST. Or, well, if you're a surfer, it's REST. Okay? If you're a high-res person, you would still not like this. Okay? All right. What does the URI of this look like? Well, this is why the high-res person would not like it. Okay, the default behavior of WCF is You get the host, then the name of the SVC file, session.svc, then the name of the method from my class, get session. Oh, see, we're using a verb there. They do not like that. Okay, get session, and then the parameters to get session come as query string arguments. That's the default behavior. And if you're a surfer, you're like, that's fine, whatever. It totally works. Okay, it's fine. But if you're a high-res person, you might get a little bent by this. Okay, we can fix that because the web-get attribute allows me to put a URI template on it. So in the template, I can say, all right, we're going to call this not get session. We're going to call this session because that's the name of the resource. Okay, and I could say session whack ID. Or I could just, I could just eliminate session entirely. That probably would be better anyway. But you can see how you can control the naming. Now, somebody asked earlier, what about all that config? That WCF config is really hard. It totally is. I absolutely agree. Now, here's the thing. Here's the beautiful thing. If you're doing REST, see, why is WCF config hard? It's hard because you could do anything, right? And we allow you, choose your transport, choose your binding, choose your encoder, blah, blah, blah. We build up a whole service description. We get this big config, and that's how you tell it. It's infinitely flexible. Infinitely flexible means this approach is infinitely complex as well. Okay, but with REST, our choices are limited. There is only one protocol transport that anybody cares about. It's HTTP, okay? We don't need to talk about anything else. There are no custom channels, none of that. So if we're doing that, then we could make a factory that could create your service and set up all the right config for REST because there's not any choice there, just only one way. So you can use, in the SVC file, the factory, system service model activation.web service host factory. That will create your service properly configured for REST. And if you look in the web config, you don't see any system.service model section at all, which is darn cool. But if you are a super advanced WCF guy and you want to write config and put system service model in there, you can still do that. It's okay. You can do both. So keep that in mind. One little point to make about this. I discovered that if you are writing a service that's going to run in medium trust, this will not work. Okay? When you run in medium trust without config, something somewhere goes looking for config in places it shouldn't and throws a security exception. Okay, so that's a bug. We're fixing it. And so it's being fixed in .NET 4. That's the current plan. If it really bothers you in .NET 3.5, you'll have to scream louder, so we'll fix it there. Okay, but anyway, that's the one thing to keep in mind. All right, let me show you this service. Okay. Still no blue screens? The pool is active. Okay. Now, the service I'm showing you is not built on the REST Starter Kit template, okay? Just to be clear about that. I'm starting with something very, very simple, but I am using some features of the REST Starter Kit. I'm going to call those out as I show them to you. Okay. So let's go out of here so I can get at my, okay. Now, we saw this earlier, but here's our very simple session data class. It's for our conference website. So we just have a class that contains some information about that. And now let's look at a service. As I said, this is just a class. It's called session, and we marked it up with service contract. Okay? So if you've never done WCF before, that attribute comes out of the system.serviceModel namespace. Okay? Now, I'm going to show you the get method. Okay. Again, I marked this with operation contract. That tells WCF that this method is accessible from the web. Okay. I put the web get attribute on it, saying, WCF, I want to use REST with this HTTP get verb. I put the URI template. Unlike my slides, I should have changed my slides. I didn't change them after I changed the code here. Sorry. I have /ID because my URI is going to be session.svc/ and then the ID of the session. Now, I just accept a string as the ID. And then I'm going to go off and look up the session in my collection of sessions. And then what if you pass me an ID that I don't have? What does the web do when you ask for something that it doesn't have? It says 404, right? Not found, okay? Well, how do I do that? Well, there's a couple of ways. One way is you could say web operation context.current.outgoing request.status code equals blah, 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 right? This line of code about that long, okay? The other thing you could do is use this new thing in the REST starter kit called the web protocol exception. And I just throw one of these and say, not found, okay? Which I like that model because if I go the other way, I have to write a lot of conditional logic around my stuff. This way, I just throw an exception and we're done. I can't find the one you want, okay? Otherwise, I just return a session, okay? Now, I did not specify the format of this response, so it's going to be XML. That's the default. And I don't have to do any XMLism here. The session class is not marked up with any special attributes. It will be serialized using the data contract serializer, okay, which is in system runtime serialization. Now, the data contract serializer is optimized for speed, which means it works a certain way. You can control some things about it using some of the attributes. I didn't put any attributes on that class, but if you want to, you can put data member attributes and name the XML type or whatever. You can do all kinds of stuff. One thing you cannot do is say, I would like this value to be an attribute instead of an element. Okay, for whatever reason, the guy said, no, that hurts the performance. So it always does elements. If you can live with that, this is going to be fine. It'll be really fast. So let's fire up our service here. We'll just take a look at our conference sessions. Okay, here we have some conference sessions. As I called into this with no ID, I just got all the sessions. Okay, and I should probably make that font larger, shouldn't I? Let's make it larger. There we go. Okay, so I called in, I got all the sessions. If I just put on here /1, now I just get the particular ID of the session I want. And let's put in a session that doesn't exist, like 0. And so Visual Studio broke in here with a key not found exception. So we're going to have a see, I should have actually, let me repair this. Okay. Because, no, I'm not going to repair it. Come on. Okay. Look, I should catch that exception and then throw the not found, okay? Or I could have said, hey, dictionary, do you contain one of those? And then, you get the point. Yeah, I'm not going to fix that. Okay. See, I shouldn't have tried that without testing that first. Anyway, okay, great. Now let's see, what about JSON? Okay, what if I am supporting, somebody was asking her, I want to write a service that supports Flex. Or maybe people who are calling in with Ajax code, maybe they want JSON data. Ajax guys love JSON. They actually don't like XML. It's easier to deal with JSON. Okay, so great. We can do JSON as well. Now, here's how we do it. Once again, I have operation contract. I have WebGet on here. And I changed my template a little bit to use a query string. So format equals JSON. And then all I do here is I say, hey, WCF, I would like the response format to be JSON. Okay? And WCF will take care of that for me. Same class is going to just deserialize as JSON. And so once again, I have my same bug. But that's because I didn't write any unit tests for this demo. See, that's what I get for not writing tests. OK. So let's look at here. I'm going to get session 1, and I'll say format equals JSON. OK. Now IE is saying, I don't know how to show application whack JSON, so I'll prompt you to save it. OK, and so we can say, all right, this is json.text. We'll save it. And open it up, and let's make that font larger so you can see it in the back. There it is. OK, so there's some JSON data. And it's very easy for me to support either XML or JSON. Now, right now, the way this works is I have one method that does XML and another method that does JSON. I know that bothers some people. They're like, can't we just have one method? Couldn't we just decide in the method? Not right now. We're working on that. There's going to be ways to do that in the future. But for right now, I have two methods. Now, you notice get session in JSON and the other one, get session. They don't show up in the outside world. Right? Nobody looking at my REST API in the browser ever needs to know that I have two methods that does that. It's an implementation detail. Who cares? All right, just leave it at that. OK. Now, let's look at one of the other things. What if I want to update a session? OK, so I can clearly update something with WCF. So this time, we're going to use an HTTP method called put. Now, with put, they're going to pass in the ID of the session they want to update, okay? And that's going to come in here as the string ID. Now, the thing to remember is that in a put request, there's a body, okay? And the body of the request is either XML or JSON data that contains the new session values for the session. So the second parameter is going to be session data, and that's going to be delivered from the body of the HTTP message, okay? I know at first that looks a little confusing because you look at the template, you say, well, there's an ID there, but where does this other parameter come from? It comes from the body, okay? So, you know, probably in an app, you're going to do some kind of validation, right? So first thing I want to do is say, well, is that session even in my collection? You're trying to update one. I just want to make sure that I even have it, right? If I don't have it, what am I going to do? I'm going to throw a bad request. Now, actually, I'm kind of glad that we saw that error earlier, because what happens if I have an unhandled exception, like I had a key not found exception? We got a status code of 500. 500 means server error. So the guy who's calling your service thinks, well, their server sucks. It's always throwing errors. I don't know what's going on there, right? So I don't want to let errors give them the wrong impression. So when they give me some bad data, I want to return bad request, because it's your fault, not mine. Okay, so keep that in mind. So I want to check the ID. I might want to check that particular session that you sent in. Is it valid? So I might, validate you got proper things in there. And then I just call into my business logic and say update it. And likewise, I have a delete session method here. HTTP has a delete verb. Again, I'm just going to look and see if my sessions list contains that. If it does, we'll just remove it. Okay? This is all just super simple, trivial code, right? I'm just showing you this because I want you to see that creating a WCF service does not have to be nightmarishly complicated and difficult. It's just simple stuff. And most RESTful services are going to have methods that look like this. Simple things like validate the arguments, just check the state of the world, throw some exceptions if you don't like it, and then call another layer, like a business logic layer or a data layer, to actually do the work, right? And this is how you could support both a SOAP API and a REST API, because your business logic layer is really doing the heavy lifting. You're just doing some simple stuff in the API layer. One other thing I didn't show you, let's just take a look at it real quick, is the append session. So appending a session, let me just call out one thing, because I didn't point this out earlier. I'm using a different verb here, or attribute rather. It's web invoke. The web invoke attribute is for anything but get. Actually, you can use get with it as well. But it just means I'm using some other HTTP verb, so you have to say what the method is. So in this case, we're using a post. I have a URI template. Now, I'm following a convention that RESTful people often use, is that I have a collection of sessions. If you post to the collection, you're saying, I want to add one. Okay? Now, what about the session ID? Well, if you're the guy that's adding a session, you don't get to decide the session ID. My server is going to decide it. Okay, so what I did here was I just go and get the max ID out of my collection and give you the next available one. And then I add that to my session list and return to you the newly added session. Now, I didn't do something in here I probably should do, which is, what status code is this going to return? A 200. That's not right. HTTP says I should return 201, means created. And it also says I should return in the HTTP header a location header that has the URI of the newly created resource. See, I knew that because I read the HTTP specification. It's great. You ought to read it sometime. I know you don't want to read it. Okay, I know you don't. I don't want to read it, but I wanted to do the right thing. So we have this problem. We want to make it easy for you to build a RESTful service, but we don't want to make you read the HTTP specification. So how can we do that? So let me just show you something kind of off the cuff here. I'm once again running a big risk, and here it is. Okay, I'm going to show you the template of the REST collection service. Now, what I had just created was a simple collection service, but I'm just going to create one here using the template. So what we did in the REST Starter Kit was we created a base implementation for managing collections of things, because it's pretty standard. Get one, get all of them, post, put, delete. It's just standard stuff, right? So you ought to be able to do this. Let's come out of here. There we go. It has come back to life. All right. So when you look at this, it's going to look substantially more complicated than what I showed you. Okay? That's why I said we're not quite done. We need to make this simpler. So some things about this might freak you out a little bit. Let me just give you a quick tour so they don't freak you out. The first thing is this service behavior. You can tell WCF how you want it to deal with, like when it receives a request. Should it create a new instance of your service? Should it reuse an existing one? Maybe you want to have a singleton, so there's only one. Okay? So what we did in this one is, well, first of all, we have include exception details and faults is set to true. So that way, if there's an error, we're going to send all the exception details to the client side. That's helpful when you're developing. You should never go into production with that, but for development time, it's a pretty good idea. The other thing we did is we set the instance context mode to single, which means my service is now a singleton. There will only be one of these created. It will be the only one, and all requests that are sent to this service will be processed by that one instance. We did another thing here, where he said the concurrency mode is concurrency mode single. That means my one service will process one request at a time, and all other requests will wait until that request is done. So they are serialized. Now, if you're thinking, wow, that doesn't sound very scalable, you would be correct. That is not very scalable. In fact, it's the least scalable way to create a service. Okay? And you say, if that's the least scalable way, why would you put it in the template? Well, we did it that way because the template implementation uses a dictionary that is not thread safe. So, okay, because the sample implementation is not thread safe, that's the only reason we did it. Okay? So you should feel free to change the concurrency mode to multiple. You should feel free to change the instance context mode, or just delete that thing entirely, and you will get per call behavior, which is probably fine for most services. Okay, I'm just telling you that so you don't worry about what that thing means. Okay, one other thing that's kind of interesting here is you see here that I have a class called service. It inherits from collection service base of T. Okay, so we have a sample item here. So remember I showed you in my conference service I declared a class called session data. If I wanted to use that here, I would just put collection service base of session data. Okay, so now it knows how to do it. It implements an interface called iCollectionService of, T. Okay, so once I've done that, all I have to do is override a couple of methods. Now I get my add, update, delete methods. I'm going to override those. This return value here is kind of interesting. An IEnumerable of key value pair of string sample item. That's kind of fun, isn't it? A generic of a generic. It's just, you got to love that. It's very geeky. Okay, if you're wondering, what on earth could I return that makes one of those? It's just a dictionary. Okay, that's it. Okay, don't let it freak you out. It's just a dictionary. So we're working on simplifying that as well. All right, so anyway, Now, why did I start telling you this? Because remember I said in my append item, I didn't do the right thing, return 201 and the location header and all that. Well, it turns out the collection service base knows how to do that for you. So if you use collection service base, when you add a new one, you get all that for free. It returns 201, you get the location header, it does some other things, it does a lot of other things for you for free. So our goal was to make you a class that would do the right things if you used it, even if you didn't know you were supposed to do them. Now, in a perfect world, of course, everyone would read the fielding and would read the HTTP specification and totally understand it, but we are all too busy for those things. So we're not there. We're just going to try to be a little more pragmatic. All right, let's wrap this up. Some futures. Remember I said there's a help page. In the Preview 2 release of the REST Starter Kit, the help page is an Atom feed. It's okay. It's not bad. We looked at it and we said, no, this isn't quite right. So I'm showing you here a picture of something that's coming in .NET 4 that your service will have an automatically generated help page for you. You can just put a little web help attribute on your class and say what the method does, and it shows up in the description. So it's kind of cool, and it has links. So if you click on Get there, you'll see an example. You get the option to get even XSD schema if it's an XML method. Now, SVC. I know some of you high-res people that will watch this will go like, I hate that .svc extension. God, I hate that thing. Okay, there's two ways to get rid of it. You can get rid of it today using the IS7 URL rewrite module. Okay, I created 4 hands-on labs for the REST Starter Kit. They're available today. I'll have a link for you on the last slide. Lab 2, the addressability lab, walks you through an example that shows you exactly how to use the URL rewrite module to get rid of SVC extensions. Now, but that still leaves you have an SVC file. Okay. Now, some people are like, you know, these SVC files, they're just kind of dumb. They're one line of text. It's just basically config information, right? It says, like, what's the name of the class that does this and what factory and blah, blah, blah. Why can't we just put that in the config file? So we said, that's a great idea. So in .NET 4, we're working on that. So you'll have something like this, where in your config file, you can have service activations. You can set up a virtual path. There won't be any SVC file. And you can name the path whatever you want. Okay, so that's going to be very nice. That's coming in .NET 4, not the REST Starter Kit, but in .NET 4. Now, what do you do now? Now that you've seen the beauty of all this and you're like, yeah, I want to get going. 2 things. Go download the REST Starter Kit. This page here, the msdnmicrosoft.com's whack WCF whack REST, is the REST Developer Center. Okay, so on there we have links to where you download stuff. You download the labs. You download videos. We have articles and things you can look at. The REST Starter Kit labs, that's my baby. I wrote all of those. There's like 100 pages of that. You can go to the code msdn.microsoft.com whack WCF REST labs and get those. And just give it a try. I created the labs so that you should be able to, on your lunch hour, whip through a lab if you want to. 1 lab, 2 labs maybe, whatever. And hopefully they're a good learning experience for you. They include unit tests and integration tests. If you're big into test-driven development, as I am, I wanted to have tests. I wanted to show how you could test a service. So there's dig in and look at those things, and you'll see how you can do that kind of stuff as well. Okay, that's it. All right, I'm going to back up so you can, if you're writing down URLs, you can keep writing them down. And we have about 8.5 minutes for questions. Okay? Let's start over here. Yes?
I was playing around with this a few weeks ago, trying to invoke WCF REST service with jQuery, and was running into strange things with message format var versus wrapped.
Oh, uh-huh.
JSON and return type. Any advice on that? I saw when you called your service, it didn't look like it wrapped it with that magic property.
Well, yeah, okay, so just to bring everybody up to speed, by the way, remember, if you want your question to live in infamy, you will use the microphone. Okay. So let's get to your question, though. The question is, you were having some issues calling a WCF REST service from jQuery, dealing with some of the wrapping or formatting of the JSON message, right? and you were noticing that my message that I was showing earlier didn't look quite like it was wrapped the same way. I have to tell you, there's no way I could understand what what the specific nature. I have not run into the problem, if that's what you're asking. But I have not tried it with jQuery, so I don't know what the problem would be. I would say that we try to give you a lot of options that control the way the serializer formats things. So you mentioned some of them, like wrapped or unwrapped or bare and things like that. They're usually driven by attributes. There's ways to manipulate it. I could only speculate about the specific problem, but feel free to. If you have a problem like that, whoa, okay, we're back. If you have a problem like that and you want to write up a little test case for me and post it somewhere and say, hey, Ron, take a look at this, that'd be really helpful. It would be a good test. Yeah, we should definitely, if there is a problem out of the box, we should fix it. Yes, over here.
How does it integrate with forms of authentication?
Okay, how does it integrate? Yeah, we have a video of this on Endpoint TV where a colleague of mine, Rob Bagby, wrote, there's a whole screencast where he walks through integrating it with ASP.NET membership. So you can watch that. But basically, when it comes to securing a RESTful service, remember, we're working at the level of HTTP. You secure it just like you secure any other page on your site, right? You can challenge, you can get credentials passed, you can use however you want to do, Windows integrated authentication or whatever. So those kind of things are pretty standard web security things. I'm glad you mentioned this because I almost forgot. There's one other thing, which is API key security. If you have dealt with, I don't know, Yahoo, Facebook, Google, a lot of them, they have something where they have kind of a process where if I want to use your service, I go to your page, I sign up, I give you my email address, I say, yes, I agree to your terms and conditions and all that, right? And then they send me an email, click this link to activate your account, click the link, come back, and then they go, here's your API key. And they give you something that looks either like a GUID or some string of random numbers, right? And they say, whenever you call our service, you must pass this thing. Why do they do this? Well, it's very simple, because on the web, there are evil people who want to abuse you, right? If I put out my conference service out on the web, and there's no security on it whatsoever, some idiot out there will write a little app that runs in a tight loop and goes, call, get, right? And my server goes, blows up, right? What am I going to do? I can't shut him off. Maybe he's running a botnet, so they're like requests coming from all over the place. So I have to have a way, a switch where I can shut off some idiot who's abusing me. So the API key is how I would do that. And so what I do is in the REST Starter Kit, the host supports what we call request interceptors. So I'm working on a lab that will come out soon, but basically you add an interceptor that gets a look at every request. When the request comes in, you grab that API key, you look it up in a database or a cache or whatever, and then you decide, okay, is this guy's key valid or not? And if somebody's abusing you, you revoke their key. That's it. And then they can't call you anymore until they sign up again. And so you put a CAPTCHA thing on your thing to prevent them from automatically signing up and stuff like that. But, it's just part of the world we live in. Other people will even take that a step farther and say, you can only call our service like, I think Twitter says 100 times in an hour. And so they, are theoretically keeping track of every time I call them. And, so there's other techniques to do, but that's very often one of them that you do. Yes, over here.
I don't know if you're familiar enough with MVC, but if I'm building an MVC app, is there an advantage why I would provide REST through WCF versus just building it through my MVC?
Yeah, that's a good question. So the relationship with MVC, at this point, is not as good as I would like. Okay. What I would really like is that the routes that you declare for MVC would just work with WCF. We're working on that. And we want it to ultimately get that way. Now, in MVC, I could just say, well, look, I'm just going to return REST data instead of a view. And in fact, the blog post I mentioned at the beginning of this talk was somebody who wrote up a nice little generic type that's a type of object result of T. And so, he kind of returns it that way. Is there some huge advantage to WCF over just writing something in MVC? I don't know. I don't think at this point. In terms of simplicity versus complexity, I think they're roughly equivalent, honestly. When I look at what it takes to do a real production REST-style service in MVC versus a real one in WCF, I don't think one is simpler than the other. It's just the only difference to me is that route map thing. So right now, the way I would control my URI with WCF is different than the way I would control it with the route map, which is unfortunate. They need to be the same, but they're not there yet. So, okay, what else? Before I forget, I should have mentioned this before other people walked out. We have this high-tech eval system here at MIX. So be sure to grab the high-tech eval and with your stylus device, check the boxes appropriately and hand them in. And would love to hear from you about your thoughts on this session. Thanks so much for coming, everybody.